Hi, welcome again to yet another session of Statistics with Python. My name is Shreya. In this session, we will learn about confidence intervals. So what is a confidence interval? Confidence interval is a type of interval estimate computed from statistics of observed data that might contain the true value of unknown population parameter. The confidence level represents the frequency or proportion of a possible confidence interval that contains the true value of the unknown population parameter. In other words, if the confidence interval are constructed using a confidence level from an infinite number of independent sample statistics, the proportion of these intervals that contain the true value of parameter will be equal to the confidence level. A confidence interval represents how much of an uncertainty would be present in a particular statistics. These are often represented using the margin of error. Confidence interval tells you how confident you can be with the results from a poll or a survey with what you would expect to find out if it were possible to survey the entire population. Let's see how we can implement confidence interval in our Jupyter notebook. Confidence interval has two limits, that is the lower limit and the upper limit, and it depends on the confidence level which you require. Here it shows as 95%, and since we are taking the lower and upper limit, the confidence level also is divided by 2. The significance level is mentioned as alpha, and this is the significance level, that is over here in our above example it is 0.025 and the upper limit would be 0.025. This represents the critical values. For different confidence level, we have different Z critical values. This can be found out from the Z table chart, or we can also use Jupyter notebook to find this out. Let us see how. So I have gone ahead and imported statistics module from SciPy library and imported norm and also imported numpy as NP. Over here, to find out the confidence level for 95%, here I am using norm of and also the module ppf, which is nothing but the percentage point function, which is also called as inverse cumulative distribution function. So this gives us the Z critical value for 95%. We always consider the value of the percentage 1 minus of the percentage divided by 2, and we add this value to find out the confidence level of the respective. And for 99, as you can see, it is 0.995. This gives us the Z critical value for 99%, and for 90% we considered 0.95. The representation of a confidence interval is given as below. So it is x bar minus 1.6, or this would be the Z critical value, into sigma by square root of n. N is the sample or the population portion. Also the sigma is the standard deviation. This would be the lower limit, and the upper limit is x bar plus Z score into sigma by root of n. We usually standardize the score, and to do that we usually consider the normal of 0, 1. So the critical region is given as 95%, and if in case the value falls under the rejected region, that is 0.25 or 0.25 over here, this region is the rejected region, and the explanation of this is coming under the hypothesis test. So what does it mean that when I say 95% confident? Suppose we have had 100 different samples of same sample size and create 100 different intervals. We would expect on an average 95 out of 100 of them to contain the true but unknown mean. Margin of error plays an important role in our confidence interval. Margin of error is the amount added or subtracted to the point of estimate to form a confidence interval. Let's see how we can go ahead and implement with an example in our Jupyter notebook. So I will be showing the confidence interval with an example which I have found online with a data set, and I'll be importing couple of libraries which are for visualization and to play around with the data set. Here I will be taking data set which is from an example, and also you can find the link for this data set in the description box. Once I have loaded the data, I can show you the data set which I have named it as scores. It has different scores for different region, and I have plotted the same using the matplotlib, and also the same histogram using the seaborn as well. If you can look at the histogram, it does not have a definite distribution. So let's see how we can use the confidence interval to interpret our data set. Let's see how we can interpret the confidence interval for our data set. Here I have also taken the length of our data as n and saved it as n, and the confidence, the level of confidence is 95%. So we can consider over here as 95%, and also the alpha level will be 1 minus of the confidence interval, that is 0.5. So this is a basic representation of how our confidence interval is. The first step is I will go ahead and find the x bar, that is the mean of our data set, and once I have found that out, I will find the sigma as well, and we will need the z critical value, and if you guys remember, we will use the stats.norm.ppf. Here we are using 95%, so the q value would be 0.975. Now that we have the z critical value, we will find the intervals for our data set, and we can directly find the intervals using stats.norm.intervals, and the alpha value can be given either manually or we can give the saved number, that is 0.5. This is the interval which we can find out, or we can go ahead and manually calculate as well. So this is the standard error. The standard error represented as 0.916, or this is the z critical value, and sigma by root of n. So I have done the same thing, finding out the upper limit and the lower limit of our data set. This gives us the values. So I'll be taking a sample over here, and also the sample size will be 75, and if you guys remember from the first video, we will take the random choice and we will randomly sample 75 values from our data set, and we will save this as df_sample. And once we have done that, we will plot it as well, so which is a little similar to our population data set. Once we have done that, we will take the x bar value, that is the mean of sample, and the standard deviation sigma, and also calculate the standard error for these. Now we will find the upper and lower limit for our sample as well. With this sample size, we are 95% sure that the population means lie in the range of lower and upper limit. Although the confidence level does not catch the mean parameter, it also has much larger wider range. Now that we have little confidence in our confidence interval, let us look into more statistics with Python in our upcoming videos. Thank you for watching. Please do subscribe to our channel for more such videos.
Acadgild. Average is dead.